Way more important after today and tomorrow's discussion. You're going to have 4 equations that you have to pick and choose from. For now, you have 1, so you know what equation you're using in number 1 already, but let's prove it. Okay, so in the first one, it says a sample of gas has a pressure of 1.0 atmospheres. Atmospheres is a pressure, and a volume of 20 milliliters, so we have a... All right, quickly, I want you to chat with your partner. I want you to share what you put for question 1. Hopefully the calculation matches up beautifully. If it doesn't, try and see what happened there. How many of you, by show of hands, tagged your units? The ATM is a what? Pressure, volume, or temperature? Pressure. So when you plug in, our original pressure is 1 ATM. The original volume is 20 milliliters. And again, you don't have to have units. You can drop those units if they confuse you. Totally fine to do that. Secondary pressure would be 1.7 ATM. And secondary volume is what you're solving for. Least number of sig figs is 2. Mrs. Williams, 20 is only 1 sig fig. Would you notice? How is it written? 20 with the decimal place displayed. That does indicate 2 sig figs. The mathematics are going to be opposite. So instead of P times V, like we had in Boyle's law, in Charles's law, we have the opposite process, which is division. We have V1 over T1 equals V2 over T2. We still have 1s and 2s. Help me out. What do the 1s mean? The initial conditions around the gas. The 2s would represent what? A change in the gas. So we're going to be able to calculate how changes in volume and temperature affect a gas. What are we going to use to convert between Kelvin and Celsius? K equals degree C plus 273. Do you have to memorize that? Where do you find that equation? Reference table T, which reminds me to remind you, you want your reference tables handy. Let's look at our first calc. Example 1 says, what is the temperature of a gas that is expanded from 2.5 liters at 298 Kelvin to 4.1 liters at constant pressure? Let's tag our units. We are solving for a temperature of a gas that is expanded from 2.5 liters. Liters is a pressure, volume, or temperature? Liters is a volume. So if you tag your units, do you see P's up there? And in fact, it says pressure is constant. That means it's not changing.